Labguy here. Today we're going to look at my attempt to externally synchronize the Denson Monoscope and my final conclusion on that. Spoiler, I'm not going to proceed with this. I'm going to restore the Monoscope to its original designed construction because it's just getting too crazy. The issue is that because the original design synchronized its scanning with the AC power line, the hum that is inevitable in this thing was standing still. When I go to external vertical sync, the picture is undulating like hula dancers. I have spent the last 2 days chasing down AC ripple in literally every circuit in the unit. I've at least doubled the number of bypass capacitors, and it's not making much improvement. So I'm not going to go any further. The design is deviating so far from the original that I'm going to stop. I don't want to end up with this becoming another Craig 6104 camera disaster, and we're going to restore it to original condition. In the meantime, we will take a look at the lead up to this and what my attempted solution was to get external sync. Inevitably, I only worked on the vertical sync, and it was successful to a degree. So let's look at those circuits right now. Looking at the original unmodified schematic of the Denson Monoscope, you can see the vertical scan circuit. It's half of a 12AT7. It is fed from the 300 volt tap of T1, the main power transformer, through an integrated network with a clipper or a clamp, and this produces the sawtooth wave, which is AC coupled up to the deflection plate of the 1698 Monoscope. The input at the 100K resistor is a 60 cycle sine wave of approximately 300 volts. When I attempted to feed in just a vertical drive pulse at 4 volts peak to peak, needless to say, nothing happened. It didn't work. So I built an amplifier that takes the 4 volts peak to peak and steps it up to 300 volts peak to peak, but still a 10% duty cycle pulse, and fed that into the 100K resistor of the integrator network. This also did not work. Now let's look at my circuitry that gives us the 300 volt pulse to drive the integrator. As you can see, it's derivative of my original sync level shifting circuit. This time we are taking the pulse and we're level shifting it to a 5 volt peak to peak and then stretching it to a 50-50 duty cycle square wave, then amplifying it to 300 volts peak to peak. The vertical drive pulse at 4 volts peak to peak comes in the video drive input jack, is terminated in 75 ohms, AC coupled into the 2N3904 transistor, which is pulled up with a 5.6K resistor. The collector is pulled up with a 1K resistor. This takes care of level shifting our 4 volts peak to peak from 0 to minus 4 volts is now converted to 5 volts and inverted. This is fed into a 74HC221 one-shot IC with a time constant of 8.33 milliseconds. This is half of the 16.67 milliseconds of a 60 cycle frequency. The one-shot's timing components consist of a 0.01 microfarad film type capacitor and a 2 meg variable resistor. The purpose of the 1K resistor in the timing circuit is necessary when using the HC221. You never take pin 15 all the way to 5 volts without current limiting. You will let all the magic smoke out of the IC chip. So we set the 2 meg resistor to give us our 8.33 millisecond time period, as shown on the timing diagram. We take the Q output of the one-shot and we send it to our MJE 340 300 volt transistor. We're pulling the collector up with a 100K 1 watt resistor to 300 volts, which I'm getting from inside the Monoscope, and then AC coupling that back into the 100K resistor of the Monoscope's existing integrator network. So at that point, it does work. The Monoscope does produce a vertical scan, and that's when the 60 cycle ripple demons come to the surface. Let's look at the picture of the Monoscope now. Looking at the image on the black and white monitor coming out of the Monoscope, you can see the result of the non-synchronous vertical scan. The sync generator is producing a perfectly good 60 cycle frequency for the scan circuit, and the scan circuit is clean. The hum is getting into the video amplifiers or into the sync circuits. Both of those circuits have bad hum in them. Let's look at the waveforms on the oscilloscope right now. We have the video output of the Monoscope on the upper trace and my 300 volt 60 cycle square wave on the bottom trace. I have adjusted the horizontal period for one cycle to be 8 divisions. So, if you look closely at the video signal, you can see right by the vertical sync pulse, right here, you can see this hump up and then hump down. It's humping up, and you can see the 60 cycles rolling through. That is enough to really mess up the image on the video monitor. I have fought with this and fought with this and fought with this. I have added bypass capacitors all over the place. I've changed the filter capacitors on several sections. On the deflection plate positioning controls, I increased the size of those capacitors by dozens of times. The hum is literally everywhere, and my guess now is that the hum is being picked up by the Monoscope tube itself. It is actually in the video. Let's look under the chassis at some of the changes I had to make. The first problem I discovered even before I attempted the sync was that over here where you see this large capacitor and this large capacitor, there were these two small capacitors installed. There is a typo on the schematic right here. Those are not 10 picofarad capacitors as they are labeled. They're supposed to be 10 microfarad capacitors, and the original builder used 10 picofarad capacitors. They're labeled 10 mmF, which in that day and age meant microfarad, which today we call a picofarad. So the first thing I did was put in a pair of 47 microfarad 400 volt capacitors. Now that cleaned up a massive amount of hump in the video amplifiers. This up here is the first video amplifier, the first 2 stages. This is the second 2 stages of the video amplifier. This tube down here is the sync and blanking tube and the final output tube. Down here are the 2 scanning oscillators. The 2 triodes in this tube are the horizontal and the vertical scanning oscillators. This transformer down here is the transformer for the horizontal blocking oscillator. In my attempt to clean up the AC ripple getting into some of these circuits, my assumption, I haven't even proven that's the case, as the picture never got better. It has been ripply like that from the get-go. I added these 2.1 microfarad 1500 volt caps and these 2 1.2 microfarad, these yellow ones right here, 400 volt caps. This circuit is the bias circuit for the deflection plates that sets the midpoint voltage for the AC coupled scanning voltages, and then these 2 resistors set the other side, the other pair of plates at a fixed level. I bypassed all of those to no effect. The ripple never changed. As I said, the ripple is getting in to the tube itself, I believe, through electromagnetic induction. I will hunt for a mu metal shield for a 2-inch CRT that will fit the length of this tube. I have some mu metal, but it turned out that it's just scrap pieces. It won't work. I have some more in storage I will look for. So in the meantime, I will be removing these 2 yellow capacitors and replacing them with their original brown drop capacitors. I will be taking these 2 additional capacitors out, which I had put in. I will be leaving the 47 microfarad caps here, here, and here that I added to the 3 video amplifier stages. In fact, in the final stage, Denson didn't have a bypass capacitor at all, just the main electrolytic filter cap over here, and that's not adequate. So these 3 filter capacitors will remain. These 4 over here will be removed. The integrator circuit will be returned to normal, and that will be the end of that. The Denson Monoscope will be left in its original design condition. So that is today's update for you on the progress of the Denson Monoscope. It's going to be left the way it was. Some things are meant to be and some things are not meant to be. We're going to leave this alone before Labguy does some damage that he's going to regret. It works well enough. It works as originally designed, and I think we should appreciate it for what it was back in the 1970s when Al Denson designed it. So again, welcome new subscribers. Greetings old subscribers. You guys know what to do if you feel so inclined. If you have any observations, leave a comment. And until next time, Labguy out.